Well, good afternoon, good morning, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar. I'm your moderator, Charlene O'Hanlon, and I welcome you. Before we get started with today's webinar, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be receiving a link post-event that you can access the webinar on demand. And also, we will be taking questions from the audience. So if you have a question for our panelists at any time during the event, just use that control panel, submit your questions, and we'll take probably about 10 or 15 minutes near the end of the webinar and go over those questions. Okay, with that, let's go ahead and kick off today's webinar, which is Introduction to Time Series, the fastest growing database category. Today, our panelist is Katie Farmer, who's in Developer Relations at Influx Data. Hi, Katie, how are you?
Good, how are you?
Doing great, thanks. Thanks for joining me. And I'm going to just turn it right over to you and let you do your thing.
Great. Well, hello, everyone, and welcome to the Intro to Time series. I like to not assume about anyone's knowledge. I never know what time series is. When I started, I hadn't heard of it, and suddenly I was working for a company that specialized in it. So today I want to talk about some of the basics. So a little bit about me. I'm Katie. I am a developer advocate at Influx Data, and we build a time series platform for metrics and events. A lot of times when I say that phrase to people, their eyes kind of glaze over, but I promise by the end, you'll know exactly what that means. Stick with me. Also, you can see that I'm sporting a pretty cool Darth Maul lightsaber. I worked hard on that. So first we want to say, what is time series data? Objectively, it makes sense that time series data is in time order. In the human world, we're pretty much stuck with time as a linear concept. But in programming, there are lots of asynchronous problems. Unexpected, unpredictable, any kind of assumptions can be dangerous. Here we're talking about data that has a natural time order, where time is not only relevant to our data, but is a key point of value. Time series data isn't just about things that happen in chronological order. It's about events whose value increases when you add time as an axis. So some characteristics of time series data are that it comes in really high volume, it has a natural time order, its value is increased by the timestamp, and it's more valuable as a data set than as individual points. So let's go over some of that as we think about weather data. Weather data, I often think can be one of the more dull examples, but it's actually one of the best examples. When we think about how weather data is gathered, essentially we have satellites or sensors or science stuff put up by science nerds who love weather. I'm not going to pretend I totally know how weather data is gathered. But what I do know is that we need weather data to come in as often as possible because we all know how quickly it can change. So it comes in really high volume. That can mean, millions of points an hour or more. And you can see from this graphic, this was yesterday in San Francisco here. Time is an axis here because without time, these temperatures wouldn't offer us any value. It wouldn't do us any good to just know it was 52 degrees because, I'm going out for coffee at 10 a.m. So I need to know what it's like at 10 a.m. So hopefully this gives you some idea of how time adds value to the data. I also want to touch on what it means that it's more valuable as a data set than as individual points. So one property of time series data is that it's suited for data where the individual points don't offer that much value. So again, if we think about, for instance, a shooting star. A single shooting star is like a magical Disney moment. you can make a wish, you can hope it happens again, but that doesn't offer you that much value. That's luck or coincidence. But a meteor shower is a forecasted, predictable event that has things like unexpected duration and a single radiant point. You know when it will start, you know approximately when it will end, you can plan for that. So a single data point isn't enough to give us context. What it also means is that because we have often millions of these points, we can afford to sacrifice a few. If I lose 1 nanosecond of data, I still have all these other millions of points to fill in the gap. So each point is not as valuable on its own. We can afford to lose a few, and the integrity of our data remains. So let's just cover an example of what is and isn't time series data. On the left, you'll see a graph that is not time series. It involves my mood and cake, as most things do. So you can see that my mood and cake are related. Sometimes they go, as I approach cake, my mood increases. Sometimes there's a law of diminishing return in the middle where I maybe have too much cake, and then I get over it and I have more and my mood improves. But you'll notice that time is not an axis here. These are relational data points, right? This is what we would think of in a more typical data set where maybe you're using Postgres as your database. This is relational data. On the right, you'll see time series. So I'm no longer measuring how cake affects me and our relationship. I'm measuring cake consumption events. Basically what that means is all I want to know is when this event happened. I had cake at 6 a.m. Clearly I have a little group of cake consumption in the afternoon, and then again at night. So from this data, we can try to gather some value, right? We could say, what happened between 7 p.m., 8 p.m., and midnight that caused this really high frequency data? Now, for me, and the cake consumption generally just means that I'm, watching reruns of America's Next Top Model and eating cake. But imagine that this was your web traffic on your store and it's Black Friday. You need to know when those spikes happen. So the time here, in the example of my cake habits, may not offer you a lot of value. I mean, it offers me value because it's cake. But for you, you might say, what do you care about happening? And maybe that's, a number of clicks per hour, or maybe it's sensor data. But the important thing is that this data is hallmarked by its timestamp and not a relationship. So I mentioned a little bit about the difference between relational and time series data on the last slide. And a lot of people use different kinds of databases to hold their time series data. Some people use MySQL and Postgres and MongoDB. And if you're using that and you have no problems and you love it and things are going great, then, continue doing that. You sound like you're doing a great job in your life. But there are reasons that we use time series databases, purpose-built databases, for the kind of data we want to gather. I'm going to touch on 3 topics: scalability, usability, and specialty. These are the reasons that we choose to use specific tools for a job, and they help us decide how to use our resources. I want to clarify that this is not to say that you can't use other types of databases to hold your time series data. You obviously can. But this is about how we choose our tools, and again, how we make the best choices for the data that we have, for our team's resources. So let's jump to scalability. We talked about how time series data is special, It's not just in the unique data that we capture, but also in the ways that we interact with that data. So maybe you're starting to use time series data from sensors in your company's thermostats, or you're analyzing historical data to make predictions about market prices. You're doing great. But new types of data, they call for new responsibilities. Time series data is evanescent and voluminous, which is to say, of course, that it comes and goes quickly and in great number. We talked about that. So this calls for different considerations for storage and retrieval. If you want to retrieve a user from a table in a relational database, you can query by any number of attributes in your schema, right? ID, last name, first name, favorite member of Earth, Wind, and Fire, whatever you care about. If you want to know exactly when your drone, and of course, in this case, you can see the Skynosaur 2000 is my drone of choice. If you want to know when Skynosaur 2000 sends its coordinates home, you can do that too. But there's going to be some trade-offs. So scalability is one of those magical words that we hear often and is used correctly sometimes. We can scale in different dimensions. So a lot of times you'll hear it's kind of a buzzword, right? People will say, oh, but does it scale? Sometimes they mean volume. Sometimes they mean, once I have 1 million users, is it still going to work? Sometimes they mean, can it scale in complexity? Time series data, especially when you consider sensors, they send complicated data back. And the more aspects of that data there are, the more complex it is. So it has to scale in a different way. So the general problem with time series and scale outside of a time series database is this. If Skynosaur 2000 flies for 1,500 hours, that's the minimum number of hours to get a commercial pilot's license. You can see Skynosaur has earned his pilot wings with his hat. After 1,500 hours, we've already reached 1 million data points for a single device. Now imagine that you're the maker of the Skynosaur 2000. Your company, Skynosaurus Rex, could have thousands of devices sending data home. So querying by timestamp would involve millions of rows of data in a relational database. And we know that relational databases do some things really well. They will make sure that it is consistent and accurate, but it's not going to be fast. Time series data is more valuable as a whole. So the database knows it can sacrifice durability for the sake of a higher number of writes. So a time series database like InfluxDB knows that if Skynosaur 2000 is sending 1 million data points home, it can afford to drop a couple if it needs to, right? If something happens while that data is being sent home and something goes wrong, we don't need every single data point to understand that, Skynosaur 2000 is still flying and that all systems are operational, or that, those processes, even if there's a nanosecond gap, we can still make safe assumptions about our data. Scalability, in this case, means that a time series database specializes in a higher number of writes with eventual consistency, even across distributed storage. And that specialty means less worry for the people that care about that data. Usability. I think this is a really important piece of every tool, something we should consider when we make choices about where we store our data, how we store it, how we retrieve it. If all of our data lived in a secure, durable black box, we could breathe easy, right? But how we access the data can be just as important as its storage. If we can't access it easily, if we can't query it easily or write to it easily, then knowing that it's safe wherever it ends up doesn't really, comfort us. So every database has a query language, right? And relational databases, that's most of the time it's SQL. But those query languages are designed to access the contents as efficiently as possible. So think about all the things we've talked about that make time series data special. That means that we need a special tool to make it usable and accessible. It can be a challenge, but it's worthwhile. Because without developer happiness, without a tool being usable, it doesn't get adopted. So I want to explain this to you more in the context of how we do this at Influx Data. One of our key sort of values here is developer happiness, mostly because we are largely developers. And almost everyone who uses our platform are developers. So without developer happiness, there's really no Influx happiness either. So what makes this easy, right? You're looking at a diagram and maybe this does or doesn't make sense to you. Diagrams to me don't always say, this is so easy to use, right? Well, let's start with the database. InfluxDB was purpose-built for time series. That means it does the things that we talked about, right? It scales and it's usable and it's special. And it was really the heart of Influx. It's the thing that we built first. And once we understood how people wanted to use it and how it was helping them, we wanted to complete that process. We wanted to make the whole, from beginning to end, we wanted to help time series data be accessible. So part of that is Telegraph, which is our agent for collecting and reporting metrics and events. Essentially, Telegraph is plugin driven. You can connect it to a service. Let's say you want to connect it to Skynosaur. In the world of IoT, you might find a plugin for MQTT, for example. You could configure that plugin to speak to your Skynosaur drone. And then you could set the output of Telegraph to wherever you wanted that data to end up. Could be InfluxDB, if that's where you want to keep it long term. You could also send it to a message queue like Kafka. The limits of Telegraph are, I guess I don't know what they are. That's the greatest thing about Telegraph, is that almost all of its plugins have been written by our community. There's over 140 of them. They range from, databases like MySQL and Postgres and Mongo to obscure services that I have not heard of, but that someone needed, and so they wrote the plugin themselves. Telegraph is basically just a pipeline. It gets data from somewhere and sends it to somewhere. It doesn't require the rest of our stack to be usable. You could send data straight from MySQL to Mongo using Telegraph if that is what you needed. Another important piece of making data accessible is making sure that you can transform data the way that you need to. And we handle that with our tool called Capacitor. It's our real-time streaming data processing engine. Now, a lot of what Capacitor does is alerting, because you don't want to watch your data all day, every day, right? This is why you're interested in setting up a process for it. Capacitor is what handles the alerts. So you can say, you know what, I don't need to know about Skynosaur every 5 seconds. It's sending data back, but I only need to know when Skynosaur's battery is running dead. Send me an alert if the battery is going to die. Or send me an alert when the memory usage on my server reaches 80%. You can also trigger actions from those alerts. So you'll still receive the alert, but you can also set up data transformation. You can spark other actions to resolve those alerts, that sort of thing. Capacitor is really powerful. It can handle machine learning algorithms, anomaly detection, or any user-defined functions that you need. So far what we have is a database, a way to send information to and from it, and a way to transform that data. The only piece that we felt we were missing was a UI layer, somewhere that you can go to manage your data and explore it without having to enter the command line if you don't want to. Personally, I love living in the command line, but I understand that sometimes I need to show data to my boss in marketing, right? And he doesn't want to live in the command line. He wants to see a graph. So Chronograph is the place where we make that happen. It's a complete interface for our platform. You can manage your alerts there. You can view dashboards. You can explore your data. Because again, if the data isn't accessible, then it's not useful. The value in your data is that you have insight into your systems, into whatever it is you're monitoring. So without this UI piece, I don't think you can argue that it is usable and accessible. Specialty. Database architecture, it's about trade-offs and priorities. So we want to talk about, why do I need a time series database for my time series data? Well, you have to ask yourself some questions. Do you need speed or accuracy or volume or maybe preset schemas? You know your data better than anyone else. You know what you need. So the important part of this process is for you to ask the right questions. You should measure everything. You shouldn't choose a tool or a product. You should choose a solution to your problem. Specialty tools like InfluxDB are made for special problems. So time series databases are optimized for time series problems. Of course, other databases can and will handle time series data. But I will probably always argue that a specialty tool will do the job better. Not because it is inherently more performant, although I might argue that it is that also, but because your time and resources matter. How you spend time making decisions and configuring databases and doing the setup, that's all time that you could be getting alerts, right? And monitoring your systems. When we say developer happiness at Influx, we don't always just mean that you like the tool, right? We mean that you don't really have to think about it that much either. An important part of the process when you're monitoring data is just to have it work quickly. By the time you realize you need to, gather your data, it's usually like you're usually already in the weeds a little, right? So it's important to think about how you spend your time and your resources, and a specialty tool cuts down that time. Time series databases are efficient, they're performant, they're going to do what you need. Choosing them for your time series data cuts down on time where you have to worry about other things. That being said, of course, I'll revisit the fact that if you're using Postgres or MySQL or Mongo, or those are clearly like the databases that I list for everything. If you're using something else and you're happy and you want to say like, I'm using this and it works great, then great, you have a solution to your time series problem. That's really what we're about solving. I do want to talk a little bit about time series as a whole. We've covered sort of what it is and why you need a special tool for it, but it's kind of a new term. I certainly hadn't heard it before last year sometime, and we've we're able to grab some data from DB engines that show us the popularity changes. And you can see in this graph on the left that time series has really gotten a tick in popularity. People are starting to realize that time series is a category and that it solves some of their problems. Now you can see relational is still on there, right? And I don't think relational is going anywhere. Relational data exists and will continue to exist. It does, relational data is always going to require like a relational database. But you can also see search and graph. We're getting more specific about what we need and want from our data. And time series is one of those categories that we're seeing growth in. I think because a lot of new industries and really booming industries are reliant on time series data. You can also see on the right some rankings of the DB engine's time series databases. So there's InfluxDB. And an important thing to sort of realize here is how many of them there are, right? InfluxDB is not the only time series database. And this really just goes to prove the popularity of the category. These databases are not easy to build. I mean, I don't think anyone has ever said like, oh, it's so easy to build a database. But when someone goes to the trouble of building a database, whether it's, another layer, a fork of Cassandra, or a layer on MySQL, whatever it is, it's a lot of work. And if this many people are willing to make tools for it, then I think that argues that we certainly have a strong use case. So I didn't mention, and I should have, that here at Influx, we love and rely on open source. I talked about it a little bit with our Telegraph plugins. Those are often contributed by the community. And our platform is open source. We have an enterprise and cloud version, but something like 90% of our users use our open source offerings, and they're really happy there. So these are some stats gathered from our GitHub. And the numbers themselves may not mean much to you, but what they mean to me is that when people visit the InfluxDB repo, that tells me two things when they start it, right? One, most of the people who visit GitHub are developers. You're not going to find too many people who aren't technical, browsing your products on GitHub. So we have a strong developer audience. And two, they are finding enough value in it to say, I need a shortcut to get back here. I know I'm going to come here again. And that also proves to me that we have this really strong community. If you go visit our InfluxDB GitHub repo and you go to the GitHub issues, you'll see conversations between dozens of people. Some of them are our engineers who work here. Most of them aren't. People use and make feature requests, and they care about this product. As one of the things that drew me to Influx when I began interviewing, because I certainly had never heard of time series, and I wasn't sure if I wanted to take on more technical debt as I learned about it. But you can't argue with a community that cares enough about this deep technical dive to fix bugs and make requests and participate in conversations about how it's going to work and evolve. Because when people ask for a feature, it means they're going to keep using it. And a lot of times, again, open source, they'll fork it and make a PR with those changes already made for us. It makes our jobs really great because we get to tell people, like, what do you want to see and what would that look like? And they can go build it themselves. We're not going anywhere. When you choose an open source tool, there, especially from when you're getting sort of managerial approval can be a little tricky. I used to use a tool called OpenOffice when I was in college, which was an open source word processor, because I couldn't afford Microsoft Office at the time. And it had a proprietary format, and I did everything in it. And then one day I couldn't open it anymore. They got bought and formats changed. And I was kind of like, oh no, what do I do? But that can be a worry in the open source community. Will it be here? Will I be relying on technology that's going away? And the way that I gauge that is I go to those GitHub repos. I look at the issues, I look at the conversations. We also have a community site, and we see a ton of activity there. And one thing I find really encouraging is that we see a lot of discussions between people that don't involve us at all. I am often on there answering questions, asking questions, but people in this community, in our influx community, are willing to help other people, because the use cases can be so specific, down to I'm using Grafana and Influx and Kubernetes and maybe Sensu, and how do I combine all of this in this very specific way, right? I might not know how to do that off the top of my head, but one of our users definitely will. So you can see that growth is not just these numbers about people who've looked at us and said, we like you. Growth is about how many people you can see posting and answering questions on our community site. It's about the number of questions asked and answered in our Slack channel, which you can join underneath the Gophers Slack. There's an InfluxDB channel. Again, I'm there, some of our engineers are there, but a lot of times before I can answer a question, one of our users already knows. You know your data and your use cases better than anyone. So when somebody has the same use case as you, you're automatically better qualified than me or one of our application engineers to answer that question. We talked a little bit about sort of the explosion of time series, right? We know that it's getting popular. We know what it is. We know where to store it. We're so smart. I'm just proud of all of us. But where are we seeing this out in the world? So there's an explosion of connected things, right? We talked about Skynosaur. I wish it was real, but it's just my dream drone at the moment. There's this explosion of connected things in the IoT world, right? Your smart homes and thermostats and your Apple Watch or your Fitbit. We want to measure everything. And that explosion of connected things, anything with a sensor is sending time series data, because sensors rely on the timestamp to make unique data. We're also seeing data-driven businesses. We're seeing adoption of monitoring processes and more business as DevOps grows in popularity. And we're seeing real-time requirements. People don't want to know what happened in their systems last year unless you're doing a historical analysis. They want to know what's happening right now, if there's something they need to fix, if there's something they need to change. Time series data, someone told me early on when I was interviewing, he said, at Influx, we model change over time, which I really like as an example of time series data. We do model change over time. And often that time is from 1 second to the next, 1 hour to the next, 1 year to the next. The important thing is that there's this factor where you need to know, and you should get to choose when you need to know about your data. We shouldn't make that decision for you. We'll make it available. If you want to know in real time, then that's your decision. If you want to, do historical analysis, quarter versus quarter, you can do that too. So we talked a little bit about it's used in forecasting, right? That could mean weather. It could mean stocks. Could mean improving machine learning algorithms. Any IoT devices, smart homes, lights, drones, anything we can connect to the internet is pretty much reliant on time series data. It's also used in analytics. We can track behavior, find patterns. And we can also use it in DevOps. We want to monitor our systems. We can use it for log and error reporting. And most importantly, we can sort of incorporate it into our decision pipeline. We have all of the data available to us that we need in order to make decisions. So you're probably wondering a little bit about influx, and one of the most common questions I get is, who are your customers? So I'm going to talk to you a little bit about some of our use cases. You'll recognize some of these companies, right? On the left, we have Tesla. Tesla is using influx data as part of their solar farms. So when you think about monitoring solar energy, there's a few things they want to know. Is it on? Is it collecting data? Is it up? Is it down? Does it need maintenance, right? Because solar panels often need to be cleaned to make sure that they're receiving the right amount of sunlight. When it comes to energy, generated energy needs to be recorded. They need records of where it was generated, where it was sold. I didn't know that was a requirement for energy companies, but it is. So they can do real-time analytics on their data. They can provide where the solar farm was that energy came from and who they sold it to. They did consider using what I'm going to call traditional IoT databases. You can probably make some assumptions about what those are, but those solutions are often really expensive. And they're not as flexible, right? Because influx is schemaless, and because we're open source, we allow for innovation. So Tesla, I mean, we don't know what they're going to do next, and it's probable that a lot of the engineers and decision makers at Tesla don't know what they're going to do next. So it's important for them to have flexible tools that they can change to suit their needs as they go on. Another use case is Comcast. Comcast is using influx data to monitor their infrastructure and their storage usage. So a lot of you probably know that hardware is really expensive. Comcast knows that too, because they had to keep buying more hardware as their storage filled up. And so they needed to know, where is this storage getting used? Who actually needs it? Where is our money going? Those are all straight business reasons to require influx data, right? It isn't even really about the time series data itself. This is a purely I need to make a decision about how much I spend and who needs this resource allocation. So they can track efficiency via containers. Monitoring is part of a container. They roll out the container with influx data running on it. Their teams use those, and they're an all-in-one container, right? They do their teams work in there, and because they're working in this container that's tracking everything they do, it's actually making it easier for those teams to justify their costs because they have evidence. They can say, hey, I wasn't just using this storage willy-nilly all over the place. I need this. I need this to do my job. And that's always an easier sell when you have the numbers to back it up. Lastly, I want to touch on a company you maybe haven't heard of, which is Bbox. Bbox sells energy in rural Africa. And they wanted their users to be able to pay by consumption. But there's no central grid there to plug into to monitor that. So Bbox sends a battery and a solar panel, and then that battery connects to different appliances, whatever the person needs. And Influx is living on that battery so that it can track the usage numbers. It can even forecast when the battery is going to reach its end of life so that users can replace it first, so they don't have to go without power. They use that data to detect patterns like, oh, more of our customers are using this at night because they need to power lights, and they live somewhere where they need to keep their lights on because maybe they have like wildlife coming up to their property, things like that. They can learn about their customers and do a better job solving their customers' problems because they have Influx data available to collect those metrics that give them insight into their own business. So what now? Download InfluxDB and its friends, Telegraph, Chronograph, and Capacitor. We're open source. It's free. It takes less than 5 minutes. It will make you happy. And you should visit our community site. You can ask questions, you can read user feedback, and it makes you happy. So tweet me anytime. I am the Catertot on Twitter, and you can always tweet at the company. I'm more than happy to take questions now.
Great, great. We have plenty of time for questions. So if you have a question for Katie, please use the control panel. Go ahead and submit your questions. And we will start with this one. How is InfluxDB different than Elastic?
Yeah, that's a really good question. A lot of times, I get asked that a lot, especially when I'm at our booth at different conferences. Elastic is really good at what it does, right? We talked about this purpose-driven tools. Elastic is really good at text search. A lot of times what people do is they use Elastic and InfluxDB together. InfluxDB is going to be better long-term storage. It's going to be better at time series data. Elastic is still going to be better at the full text search, but what I have seen people do is set up configurations so that data goes to both, so they can store the full data in Elastic, the full text. And then what they send to Influx is some of the metadata. They send the timestamp and an ID or whatever measurements they care about. The important thing to think about when you're choosing, like where do I want to store this data, is to say like, what is this tool going to be best at? What problem is it going to solve for me? Elastic will solve, full text search problems, but it's not going to solve your time series problems necessarily.
Okay, great. Next question. How can I contribute to this project?
Yeah, that's what I like to hear. You should visit our GitHub. On GitHub, we're just InfluxDB. And I would encourage you to look through the source code. We are written entirely in Go. Chronograph is our UI layer. It's got a little bit of TypeScript right now, a little bit of Go, some plain JavaScript. It's got a lot going on, but we love contributions. We love people who have better ideas than we do, heck. And we'd love your feedback. So if you go onto our GitHub or our community site and you download the stack and you use it and you say, this is not doing what I need it to do, I would love to know that, because that's feedback that we need, right? We want to solve your problems, and if we're not solving them and no one tells us, we will just happily trot along not solving your problems. But please tell us. And if it's not doing something you like, then you can fork it and make your changes and make a PR and say, this wasn't handling my use case that well, but now it is. And I think that's actually how we hired a couple of our engineers.
That's great. That's great. Okay. Next question. How does Influx handle typical database security concerns?
That's a good question. So we do have some auth enabled. I will say that the security is heightened on the enterprise and cloud versions. On the open source, a lot of times You can set permissions on the database, but not on as fine-grained a level as you can on the enterprise and cloud versions. So in enterprise and cloud, you can control who sees what data. For instance, my coworker Anna and I might be on the same team, but she and I need to view different types of data, right? I want to view developer statistics, and she wants to view marketing statistics. So in the enterprise version, I can set permissions all the way down to say, Anna sees only marketing, and Katie sees only developers. In the open source, you can set usernames and passwords on the database, more basic things, but you can't get like all the way down to those maybe like finer security problems.
Okay. All right, great. Just a reminder, there's still time. If you have a question for Katie, just use that control panel. Go ahead and get your question in. Our next question is, let's see, I am a performance test engineer. Well, not me, but Paul, who's asking the question. On the community site, are there any specialty groups where I could possibly find and collaborate with others trying to do the same thing?
You know, on the community site right now, there aren't groups per se, but there's a nice search feature where you can find people who've been doing benchmarking and performance tests. I have seen posts about it before. There's not like a group, but if you are in our Slack channel, that would be an excellent place to look too. So if you're part of the Gophers Slack, which is the official Go Slack, then there's a channel in there called InfluxDB. And some of our most active users are in there, sort of talking to each other, asking questions, and reporting back on their sort of use cases and experience a lot of the time. So that might be a good place to start. But I would just love to hear what you have to ask. If even if there's no group, if you wanted to post on the community site and ask for feedback or ask where you can find that information, then me and my team can figure out where those people are and get you to them.
Awesome. All right, great. Next question, is there support for collecting audit logs from Azure?
That is an excellent question. I'm pretty sure that we are working on our Azure integrations at the moment. I don't know specifically about those logs, but we have been working with Microsoft recently on our Azure integration. I think it's still in process, but hopefully it will soon be available.
All right, great. Next question. I'm having trouble figuring out what my use case would be for this. As an example, could this be used for IP log data?
Yeah, so that's a good question. We get that a lot. That depends. I mean, that's sort of the cop-out answer, right? It depends. But it depends on what you need from your log data. So if you need to store, again, like the full text of those logs, then maybe you want a text search, right? Like Elastic or something. But a lot of times what I see people do is they send the full log information to something like Elastic, and then they send more consolidated data to Influx, especially because the thing that Influx does really well is sort of roll-ups and aggregates. So sometimes you want to be able to dig down into your log data and see specifically what happened, when was it, what was the full error message. But a lot of times what you want to know is, how often did this happen, or what was the average, that sort of thing. Influx is going to help you do those roll-ups and aggregates better. And that's when we sort of see people using both, if that makes sense.
Okay, great. Next question. Can I use InfluxDB for standard SQL layers and NoSQL? And then second part, how does it treat the issue of machine learning or artificial intelligence within the context of systems and flow of large volumes of data?
That is a super good question. I'm not sure if I know like the what I'm going to call the 100 level truth on it, but I will say that you can put, because InfluxDB doesn't restrict the type of data you put into it, then you can certainly try to insert data in a more SQL or NoSQL fashion. I will say that you can't really, there's not a good way to represent relational data in a time series database. So that wouldn't be a good use case for it if you needed that relational data. Can you repeat the second part of the question, please?
Yeah, sure. How does it treat the issue of machine learning or artificial intelligence within the context of systems and flow of large volumes of data?
So I'm not sure I know exactly what they mean by this, but I will say that in use cases where we see people using machine learning and AI, the process generally looks like so we have an influx data cluster, right, which usually involves the database, maybe Telegraph if you're collecting data from somewhere, and then it usually involves capacitor, right? So when we are used in a machine learning context, we rely on outside algorithms, right? So obviously we don't do machine learning, we don't have algorithms, but capacitor allows you to reach out to whatever machine learning algorithm you're using, whatever that may be. And a lot of times what we see is that, so let's say capacitor hits an API, it does some transformation on your data, uses the machine learning algorithm, and then you pipe it back into InfluxDB. A lot of times what we see is, once that data is transformed, we see people mostly using it for alerting. Are your systems still running? Are they still training? Are they still learning? But you could also import historical data if you wanted to just like find patterns, that sort of thing. That's sort of that's the use case I've seen with it in the open source world, is most people are using it for alerting just to make sure that their various like agents are out there still learning and training. There are definitely more sophisticated use cases from people who know more about machine learning than me, obviously. There are a few people on our community site who've posted about it, so that would be a good place to look.
Okay, all right, great. We do have a couple minutes left, guys. If you have a question for Katie, go ahead and put it in. Right now, that's all the questions that we have, but like I said, if you've got a question, go ahead and get it in now. While we're waiting, I do want to remind the audience that today's event is being recorded. So if you've missed any part of the event, you will be receiving an email after the event that will have a link to the webinar on demand. And you can also actually get to the webinar on demand on the devops.com website. And we're not getting any more questions in, so I do want to thank Katie Farmer for giving such an awesome Dinotopia presentation today. It was pretty amazing. I really, really enjoyed it. So thanks very much. And then thank you to everybody who did submit questions. And thank you all for joining us today. We do have a ton of other webinars posted on the devops.com website. So if you have a couple minutes and maybe you're there accessing the webinar on demand, just check out the other webinars that we have listed there. Hopefully there'll be one or two that pique your interest. Katie, again, thanks so much for your time. I appreciate it. It was a great webinar.
Thank you.
Yeah, great. All right, guys. This is Charlene O'Hanlon signing off. Have a great day, everybody.